All right, in this example, we're given an inverse variation equation and asked to graph it. Our equation is y equals 3 divided by x. And for this type of equation, it's best to use a graphing calculator to help you sketch out a graph because as we're going to see, it has kind of an odd shape to it. Now, you could also pick a set of x values to plug in by hand here and calculate the corresponding y values and then graph all those points. That's certainly fine. But for the sake of brevity and some practice with the calculator, we're going to do this one using our graphing calculators. All right, so how do we generate a graph on the graphing calculator? The first thing we need to do is we need to hit our y equals key, and we need to type our equation in. Once we have our equation in, we go to the upper right-hand corner of the calculator and we hit the graph key. Now, if your calculator is in a standard zoom window, what you'll see is this kind of strange graph consisting of what looks like to be two different curves. Now, these in fact are actually not two different curves. These in fact are one whole equation, one whole function that have in between them, in this case, on the y-axis, what is called an asymptote. And an asymptote, in layman terms, is kind of like an imaginary wall that a function can't cross. And so one way of thinking of this is this function approaches from the left, comes across, starts dropping, boom, plummets all the way down as it hits this imaginary wall here, this asymptote, and then it blinks out of existence and reappears up here, and then comes down, getting closer and closer to zero, and moving out to the right side. So we do have, in fact, one equation here. These are not two separate graphs. These are not two separate functions. These are, in fact, just one function. All right, now, how do we graph a shape that is a shape like this? A strange looking, this isn't a line, this isn't a quadratic function, a parabola, a cubic function. How do we graph something like this? Well, on the calculator, if we hit second and the graph key again, it's going to bring up a table of values. So I hit second, hit the graph key, and now I can see I have a table of values. And in fact, I get an error here at x equals 0. That's because that's where our asymptote, that imaginary wall, is located. So how I'm going to graph this is I'm going to get some points on the negative side to get kind of the negative part of my graph. And I'm going to get some on the x-axis, that is. And then I'm going to get some positive x values to get the positive side of my graph. Now, how many points do you need? Well, to make a really good shape, it's probably good to get 4 or 5 on each side, though bare minimum you could probably do with 3 to sketch out just a rough shape. For the sake of this video, I'm going to attempt to do 5 on each side so that we can get something that looks nice. All right, so I'm going to start at -5 for my x value and start plotting my points. So the first point is located at -5, -0.6. So I'm going to move to -5 on my x-axis, and then I'm going to move down 6/10 of a unit, which would put me just about right in here, which of course, you can't graph these perfectly, just do the best you can. That's about halfway between 0 and -1 on the y-axis. All right, our next point is -4, -0.75. So I'm going to go left 4 on the x-axis, and I'm going to go down a little more than I did last time. I'm going to go down 3/4 of a unit. So I'm going to position this thing just right above the -1 line for the y-axis. Okay, next point is -3, 1. So I'm going to go back 3 and down 1 exactly. Our next point is -2, -1.5. So I'm going to go back 2, and now I'm going to go down 1.5 units. So about right there. And then finally, we're going to do -1, -3, and that will be our final negative value for the x's. So I'm going to go left 1, down 3, and plot a point, if it'll allow me to. Sorry, my board's a little finicky. Okay, and that's about the best I can do in terms of the shape. And then what I would do is connect it with a smooth curve. Again, I have issues with my board here, but you can kind of see what I'm doing with a smooth curve to the best of your ability. All right, so now I'm going to go over to the negative side of the the positive side of the x-axis, and I'm going to plot 5 more points, starting with x equals 1. All right, so on the right side, we have 1, 3. So I'm going to go over 1 to the right and up 3, plot a point. My next point is located at 2, 1.5, so I'm going to go over 2 and then up 1.5. Should be about there. Our next point is 3, 1, so I'm going to go over 3, up 1, about right there. Next is 4 and 0.75, so right 4 units and up 3/4 of a unit, about right in there. And then finally, I have a point at 5, 0.6, so I'm going to go right 5 units and up about 6/10 of a unit, which is about halfway. So somewhere about right in there. And then I'm going to try to connect these the best that I can with a smooth curve. To get a rough graph of my inverse variation equation.